All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we have a pair of compound lever snips are used when we're cutting large, or when large cutting forces are required. So we're cutting a wire is what it looks like we're doing here. We're saying we're squeezing with the force of 150 newtons. We're squeezing with about 35 pounds, which is a pretty doable thing. Let's determine what the cutting force on the wire ends up being. And in addition, we're going to figure out what's going on at A and at B. So let's come in and tackle this. We approach this the same way that we do frame problems. We're set on a frame, we want to figure out, do we have any two force members? Then can we find our support reactions? And then we exploded the object into pieces, made free body diagrams of each piece, applied equilibrium, and solved everything out. The same idea is going to be true in a machine, other than the pieces a lot of times are more awkward to look at and figure out what am I even seeing. And there's times that we don't have support reactions. Like with a pair of wire cutters, there really isn't something that's holding this to the wall, holding it to the ground, anything like that. We should be able to pick this up and carry it around. The support reactions are just the squeezing force on there. So we can skip that step and just go straight to, do I have any two force members on this? So I've taken my given picture and I've exploded it already just to make it easier to come in and analyze. My two force member would be, just look at where we have forces. Any member that has forces in only two locations is a two force member. Remember, CD has things at C and at D. I could come in and say, well, that is a two force member then. If it's a two force member, I should have equal and opposite forces at either end that just go along the member. So I'm going to guess in here that at point C, I have FCD going straight up. And at D, equal and opposite, I would have FCD going straight down. I also know, and I'll go ahead and make this consistent assumption, as I move from one member to the next, I need to have equal and opposite forces. So I have point D down at the bottom here. That connects into point D on this piece. I should have an equal and opposite FCD. If FCD went down before, it should now be going up. Same magnitude, FCD, opposite, instead of going down, it's going up. And that's just applying Newton's laws. For every action, there's an equal and opposite reaction. At pin D, our equal and opposite reaction is FCD. That same idea is true. I had pin C on my two force member. Pin C also connects in on this member. I should have an equal and opposite force. It went down on the, or up at C. So over here, I need to show that going straight down. An FCD. I would also come in at about this point and let's name our members off. For our frames, it was really easy to be like, oh, I remember AB. On a machine, that gets a little bit trickier at times, so we just kind of come up with names for each member in here. So I'm going to say, let's call this one the lower handle. Lower handle. Lower handle. That way we can talk through what we're working with a little bit easier. Our two force member we'll just leave as is. This one is kind of that piece that comes up and is the top half of what's actually cutting the wire. So I'm going to call this my upper jaw. Upper jaw. And then this one, that goes down to the bottom piece on that. Let's call that the lower jaw. Lower jaw here. I have four pieces I could come in and work with. I don't necessarily need to use every single one of those, but we're going to have to tackle some of them in there. So what I look forward to when I'm trying to start these out then is, if I were to finish my free body diagrams of them, where's somewhere that I would have one known force and ideally just three unknowns. So if I looked at this lower jaw, for example, I do have a known force, 150 newtons, but at B, I'm going to have BX and BY. At A, I'm going to have AX and AY. And where I cut the wire, I'm going to have a fifth force there. 5 total things, too many unknowns. At the upper jaw, I'd have FCD, I'd have AX, AY, and my upper cutting, or my cutting force. 4 unknowns there, no known force. On my two force member, I only have FCD. There's only one unknown, but there's nothing known. If I sum forces in the Y here, all that I get is FCD minus FCD equals 0, or really it's just 0 equals 0. That's not a useful equation for us. On that lower handle, though, I have 150 newtons is known. I have FCD, and at B, I would have BX and BY for a total of 3 unknowns in there, FCD, BX, BY. So let's finish this free body diagram, and we're going to start there. Let's put on this one, I'm going to assume that by goes straight up. So coming up off of this, I have by. And then let's guess the bx goes to the right. We're just taking a guess at that one. bx. We can come up and we'll just do it right here. Let's apply equilibrium and find it. We're doing machines. I oftentimes label what free body diagram I'm working with. This is my lower handle. So what should we do first? I have one unknown, the x direction, bx. Let's actually start there. That's a pretty easy one for us. If I sum my forces in the x, I know I have bx, and that's it. I don't have any other x force on here. I can set this equal to 0, equals 0, which gives me one of my answers. Bx is 0. I don't need to say like a direction on there or on which member, even though it's an internal connection, because 0 is 0 in any direction and on every member. There is no force in the x here. So we'll just box that and move on. Let's sum moments at B. That would get rid of by. I can find FCD. So with positive going counterclockwise, I'm going to sum up my moments about point B. That'll get me, well, FCD will cause a counterclockwise rotation, and it's 30 millimeters away. So 30 FCD. Our 150 newtons will cause a clockwise rotation, and it's 30 plus 80 away, 110. So minus, because it's clockwise, force 150 times distance on 110 equals 0. Or solving for FCD, I'm going to get a positive number for FCD, which means I guessed the right direction on this. I'm going to end up with FCD, the force in member CD, is 550 newtons, 550 newtons, and it's going down because I guessed, I get a positive here. This guess on the free body diagram I'm working with was correct, going down, and we'll say that on the lower handle. On lower handle. That's not an answer for us, but it's useful. I'm going to underline that so I can find it easier when I'm working through everything. If I got it correct here, because I make consistent assumptions on everything, that also means it's correct on my two-force member. I could have presented this as FCD is 550 newtons. If I look at that two-force member, I'm showing an intention. I have equal and opposite forces, pulling it apart. I could just say 550 newtons, tension. And that would have been acceptable. Or I could have come over here. This one also has the correct direction. I could have said it's 550 newtons going up on the upper jaw. That also would have gotten me a valid answer in there. Really, we got to account for that. Newton's laws tell us as we move from one connection to the next, it's an equal and opposite force. We're just fully documenting when we say our direction, where we're actually saying it's going that. So get that whole thing in our answers. But our last thing, I can get by out from this. If I just sum my forces in the y, summing forces in the y direction. I have by coming up. I have FCD going down, so minus FCD we just got was 550, minus 550. And I have that applied 150 Newton force going up, plus 150 equals 0. Or I can solve that for by. It'll be my second answer in here. I would get that by is 400 newtons. And it's going upwards. We know it's going up because I get a positive number when I solve this equation. So I'll say it's going up on my free body diagram. I get a positive, which means I assume the correct direction here. Up on, we were looking at the lower handle. Lower handle. And that's another answer for us. Let's go ahead and replicate bx and by. Bx is 0. I can just leave that off from every free body diagram from here out. But I can put in by. By connected with my lower jaw. If it went up here on the lower handle, then on the lower jaw, it should be opposite. I should show this going straight down here at B. That is my by. Equal and opposite. It still is 400 newtons, but in the opposite direction, pointing down now. Bx we technically could do that with, but because it was 0, I could just leave it off here. It still is 0 in any direction. So let's not overcomplicate it. My three things I need to find still, though, are AX, AY, and my cutting force. I can do this with either free body diagram. Pin A shows up on both the lower jaw and the upper jaw, and my cutting surface would show up on both as well. It's a toss-up in here. Let's work with our upper jaw to tackle this. So I'm going to label it. We're dealing with the upper jaw. Upper jaw. And then we'll come in and fill in our free body diagram. So I need AX and AY. Let's start there. I'm going to go ahead and guess on this one. Let's say that AY goes down. So it's about right here. AY goes straight down. And let's show AX going to the right. AX. I'm going to move where I'm showing that at because that's going to hit the cutting force. AX goes to the right. And I can label that here. AX. Gets a little crowded at times, but that's okay. I can also get my cutting force in on this. Should be about right here. I'm just going to call that force F. What is my cutting force? Which now looks like I've written fupper. So let's move that. This was my upper jaw. Upper jaw. But I have that free body diagram filled in. If I wanted to work with the lower jaw, I could do that. I would just, now that I've assumed one of these, have to make equal and opposite assumptions. AY would now go down. Going straight down, we get AY. Same magnitude, still AY. But opposite, we are going down here because we assume, sorry, I just lied. We should be going up on that because I assumed it was going down. I had that backwards, what I was doing. Going up right here. Equal, still AY. Opposite, going up instead of going down. AX, I assumed went to the right. So now I should put this in here, pointing over to the left. AX. And then finally, my cutting thing was going up on the upper jaw. That means it should point down on the lower jaw. And we can put that in as well, going straight down. F. And either free body diagram will get me to the same final answers for everything. This one's easier for me because I don't have to deal with By in here and my 150 Newton force. It's just one less force if I work with the upper jaw. So let's go there. Let's sum forces in the X first. If I sum my forces in the X direction, all that I have here is AX. So it is 0. AX equals 0. My next piece, I could come in and say, well, let's do moments. I have two unknowns in the Y, AY and F. So let's not start by summing forces in the Y. Let's do moments first. So with positive being counterclockwise, I'm summing my moments up. Let's sum about point A. If I do that, F is going to cause a clockwise rotation, so it's going to be negative. Negative, my distance is 80. Negative 80 FCD equals negative 80 FCD. AX and AY go away. Also, I know FCD. Let's fill in its known value. Rather than putting it in as a variable, I know FCD is 550. So negative 80 times 550. F would be my only other force in here. What's my cutting force? It is 30 millimeters away. So I could say plus, it causes a counterclockwise rotation, 30F equals 0. We're solving for my cutting force. I'm going to get to my cutting force here. F is equal to 1,467 newtons. That's going up. I get a positive number from this equation, which means I guessed the right direction here. So up on the upper jaw. On upper jaw, which would be my next answer. The final answer I need is, what's AY? With FCD and F known, I can just sum forces in the Y and get this one out. Summing my forces in the Y direction. I have FCDs going up. FCD was 550. 550. Even though we wrote it was down, that was on the lower handle. I'm now working with the upper jaw. The direction is correct here. It is going up on that one. Equal and opposite. Plus F plus 1467 minus AY. Minus AY is going to get us to 0. AY is our only unknown in here. If I solve for AY, I'm going to get that AY is 2,017 newtons. I'm getting a positive number out from this equation, so my free body diagram has the correct direction soon. Even though it's acting in the negative direction, we have the correct sign here, is what we're saying. This is going down on the upper jaw, which would be my final answer for our problem. Again, make sure we're getting our magnitude direction on which, remember, it really clearly articulates what our work is actually leading to in there. Makes it easy for someone to come in and follow our work and use our work in later stuff if we needed to. But hopefully this is a useful video for you. If it was, hit the like and subscribe buttons. Stick around. Let's get you an A with JJ.